Bohr's atomic model. The drawbacks of Rutherford's model were removed by Niels Bohr in 1913. Bohr proposed a new atom model. Bohr applied the quantum theory of radiation as developed by Max Planck and Einstein. The model proposed by him is based on the following postulates. Postulate 1. Stationary states. The electrons revolve around the nucleus in certain allowed circular orbits only, and while in these orbits they do not radiate energy, that is, electronic orbits are stable. The necessary centripetal force for their circular motion is provided by the electrostatic attractive force between the positively charged nucleus and the negatively charged electrons. If Z is the atomic number of the nucleus and R is the radius of any electronic orbit, then mv square by R equals to 1 by 4 pi epsilon naught into Ze into E by R square, equation 1, where m is the mass of electron and v is the velocity of electron in the allowed orbit. Postulate 2. The allowed orbits in which electron can revolve are those in which the angular momentum of an electron is an integral multiple of h by 2 pi, where h is Planck's constant having a value 6.63 into 10 power minus 34 joule second. That is, if m and v are the mass and velocity of the electron in a permitted orbit of radius r, then for the stationary orbits, r into mv equals to n into h by 2 pi, equation 2, where n equals to 1, 2, 3, and so on, and is known as principal quantum number. The above equation is also called Bohr's quantization condition. Postulate 3. According to Bohr's model, the electrons don't radiate any energy till they revolve in their own orbit. That is, orbits of electrons are stable. The energy is radiated the only one and only when an electron jumps from higher energy orbit to lower energy orbit and the energy is absorbed. When it jumps from lower energy orbit to higher energy orbit, both the radiation and absorption of energy takes place in the form of photons. If EI and EF are the energies associated with the orbits of principal quantum numbers Ni and Nf respectively, Ni greater than Nf, then the frequency of the emitted radiation is given by h nu equals to Ei minus Ef, equation 3. The above equation is called Bohr's frequency condition. Bohr's theory of hydrogen atom. Hydrogen-like atoms are those which consist of a nucleus having positive charge plus Ze and an electron having 1 unit negative charge revolving round the nucleus. These are basically ions like helium plus, lithium 2 plus, etc. These ions are called hydrogen-like atoms. Suppose one electron having a charge minus E and mass m is moving in a circular orbit around the nucleus having positive charge plus Ze in some hydrogen-like atom. Let Rn is the radius of some nth allowed orbit and Vn is the speed of electron in that orbit. Radius of nth allowed orbit. The electrostatic force of attraction between the nucleus and the electron is given by F equals to 1 by 4 pi epsilon naught into Ze into C by Rn square equals to K into Z square by Rn square, where K equals to 1 by 4 pi epsilon naught equals to 9 into 10 power 9 Nm square by C square. This force provides necessary centripetal force to the electron. Therefore, mvn square by Rn equals to kZe square by Rn square, equation 1. According to Bohr's first postulate. According to Bohr's second postulate, we get mvn Rn equals to nh by 2 pi, or Vn equals to nh by 2 pi mRn, equation 2. Substituting equation 2 in equation 1, we have m by Rn into n square h square by 4 pi square m square Rn square equals to kZe square by Rn square. Rn equals to n square h square by 4 pi square kZe square, equation 3. When we put z equals to 1 in the above equation, we will get expression for the radius of hydrogen atom, which will be represented by Rnh. Rnh equals to n square h square by 4 pi square mke square, equation 4. Important points. A. From equation 3 and 4, we find that Rn z equals to Rn h by z, equation 5. B. Rn z or Rn h directly proportional to n square or Rn z or Rn h equals to Cn square. Hence, R1 z equals to C, R2 z equals to 4C, R3 z equals to 9C, R4 z equals to 16C, and so on. Equation 6. This shows that separation between successive orbits of hydrogen-like atoms or hydrogen atom goes on increasing as we move towards higher orbits or away from the nucleus. Orbit closest to the nucleus is called as n equals to 1 orbit, while farthest from the nucleus as n equals to infinity orbit. C. The radius of the innermost orbit in hydrogen atom, that is R1h, is called Bohr's radius and is represented by A0. It is a universal constant. That is, A0 equals to R1h equals to h square by 4 pi square mke square. 6.6 into 10 power minus 34 whole square by 4 into 3.14 square into 9.1 into 10 power minus 31 into 9 into 10 power 9 into 1.6 into 10 power 19 whole square meter equals to 5.29 into 10 power minus 11 meter equals to 0.529 angstrom. D. Radius of third orbit of a hydrogen-like atom, lithium 2+, is given by, according to equation 5 and 6, R3 lithium equals to R3 H by Z equals to 9R1 H by Z equals to 3R1 power H equals to 3 into 0.529 angstrom equals to 1.587 angstrom, since Z equals to 3 for lithium 2+. Similarly, radius of second orbit of a hydrogen-like atom, helium+, is R2 power helium equals to R2 power helium by Z equals to 4R1 power H by Z equals to 2R1 power H equals to 2 into 0.529 angstrom equals to 1.058 angstrom. Z equals to 2 for He plus, where alpha equals to 1 by 4 pi, 2 pi E square by Ch. It is called fine structure constant and has got no dimensions. It is a universal constant having a value 1 by 137. The velocity of electron is nth orbit of hydrogen atom is given by Vn power h equals to 1 by 137 c by n. Hence, the speed of electron in the first orbit of hydrogen atom is 1 by 137th part of the speed of light.